go.
All right, we're still in my dirty sink, and I just talked about cavitation. And
Isn't this lovely?
Oh yeah, this is great. My lovely assistant came up with this.
He kept losing his glasses, and so I made him this lovely.
It's my low budget karaoke.
Anyway, go
It's
ahead.
great. Look at that. And I don't lose my glasses, except when I don't remember where they are anyway. Which is the case.
Okay.
So we had a conversation a while ago. What were we watching? Oh, we were watching Tiny Houses, I think what it was.
Okay.
And they were building a barge. And they were filling the barge with concrete.
Yes, and I was like, how does that float?
How does it stay afloat, right?
Because I don't know how that floats.
Right.
Why would I know that?
Right.
Like, isn't it heavier? Mm-hmm. Concrete's heavier than water.
It has to do with density. So so I just kind of started to think about that because I did a cavitation video and I have my nice floating pot here. So I was saying, well, look, metal. How come metal's heavier than water? Why is it floating, right? The reason it's floating, something will float, let's see, if the mass of the object, if I get this right, has to be, I think, less than the volume of water that it displaces. It has to do with the density. So the density of the object has to be less than water for it to float. That's why it works.
So since that is thinner, the density
can be heavier. It's thinner, so it can be. So the metal's heavier. Well, it has to do with the density, which is the amount of stuff you can pack into a certain amount of volume. That's what density is. So I don't know if that makes sense. So that's how shipbuilding. I'm not a shipbuilder, but that's how shipbuilding works. Or if you build a boat, that's how they get these big, massive ships to float, even though they're like wicked, thousands and thousands of tons. It's because of the amount of water that the boat is displacing. I think it has to be less or equal to the amount, the total mass of the vessel that's sitting in the water. If the vessel is too heavy or has more density, then it'll sink. So that's all. Does that make any sense? No.
Kind of. I mean,
and I'm not sure how to demonstrate that.
You're demonstrating it right there.
Well, I'm demonstrating it right here because this is metal, right? And you think, it's copper. It's copper and stainless steel. It's pretty heavy, pretty heavy. But yet,
that didn't really tell us how heavy it was.
That's true. I can't quantitate it. I don't have a scale or balance. I do downstairs. Oh, I do actually.
Oh.
Well, let's see. I do. I don't know if it's. I don't think there are any batteries in it though. It may be too heavy. But here's my.
All right.
It's maybe more than you could. Oh, we might lose power here, guys. We're experiencing a bad New England storm, coastal storm right now.
Why do you keep the batteries not in there?
So it doesn't deplete the batteries. So it doesn't drain the batteries as quickly. The batteries will drain just sitting there, but more so if they're hooked up to a device, and then they'll get leak. It still works, maybe. Errors detected. That's not a good sign. I haven't used this in ages. We'd probably have to get a bathroom scale, but I'm not going to do that. Yeah, it's not working. Because what I could do is I could get the mass of this pot, figure out the mass. We could figure out the density of the pot by taking distilled water and filling the pot with distilled water and then getting the mass of that. And so by subtracting the mass of just the pot and the mass of the distilled water and the pot, you could figure out the mass of the container.
So the mass is just the weight.
Weight, yeah, it's weight essentially. Yeah, let's just call it weight. Yeah.
Yeah,
weight.
that I can understand.
Okay, so the weight. Sorry. So then you can figure out the density because the density is the mass divided by the volume. So we could figure out the volume of it by the weight of the water that went into it. We know the density of water, we can calculate. If we know a density, we know a mass, we can calculate the volume. And we can just do a calculation to
Is this algebra?
Yeah, maybe. Not really. I don't know, maybe.
I haven't done math in like
I'd probably have to draw it out
35 years.
in like a chalkboard or something like that. But anyway, so you can figure out the mass and the density and everything, and you can actually prove that this is true, what I was telling you, if you wanted to.
All right.
Maybe I'll do that.
Something to do tonight.
That would be kind of fun.
Prove that Stephen is wrong or right.
Or wrong. That might be more fun. That's how scientists works. Is someone comes up with a theory, an idea, and usually people are out there trying to prove it wrong, and try to disprove things wrong. I try to disprove things, and then if enough people try to disprove it, and it actually keeps working over and over and over again, it becomes more accepted and becomes an accepted practice or an accepted theory or an idea. That's how science kind of works. Anyway, so that's called the scientific method, in essence. So, all right, that's probably way more than I needed to talk about. Sorry.
That's it. Let's have some soup.
Let's have some soup.